run, a skier of mass 80 kilogram slides up. Okay, a rough slope at an angle 10 degree to the horizontal. So draw one rough slope which is 10 degree to the horizontal. So 10 degree, now you can just little extend the horizontal line, that will leave for the reference. No need to extend this line and mess up with the diagram. Just little bit enough. Okay, we have to show that 10 degree to the horizontal. Okay. Then so step by step, whatever given now, you put it to the diagram. See down here, a skier of mass 80 kilogram slides up. So it's going to slide up. So let's draw here. Mass 80 kilograms, which means 800 Newton down. Okay. So he arrives at the upward slope with an initial speed. Arrives means the starting point we drew here, no problem. So that is U is going to be 12 meter per second. The coefficient of friction that is given what? Mu is given 0.4, which is 40% of the normal reaction. Find how far up the slope he comes to rest. See, when he comes to rest, now what will be the velocity? So he will go for some distance, then it comes to rest, mean that point velocity is going to be 0. Okay. So what we have to find here? How far means does it mean time or distance? So they ask us to find the distance, how far it goes up. Okay, so S to be found. So S to be found, U is given 12, B is given 0. So what is the required still? You can find A, no? You can find A by using the Newton's second law. So resultant force B equal to mass into acceleration. Now you tell me what are the force acting on a particle? Weight is acting here, so I can draw one perpendicular to the plane, one parallel to the plane. Okay, so that means what? The 10 degree will come over here, which means 800 sine 10 will be here. 800 cos 10 is going to be here. What are the force to be marked? Or normal reaction to be drawn. So normal reaction that is perpendicular to the plane. So it will be correctly perpendicular to the plane. Then still friction, which side will lag? Slides opposite direction will lag. Okay. So friction is going to be this side. Okay. So friction can be found, right? So the particle accelerating this side, right? Which means what? Vertical direction, it is equilibrium. So correctly perpendicular to the plane, it is equilibrium. So what are the forces acting perpendicular to the plane? So R is equal to 800 cos 10 degree. So we know R means how many percentage of R is going to be friction? 40%. So friction is equal to mu into R. So mu is given, coefficient of friction is given 0.4, 800 cos 10 degree. And tell me, what is the value of friction over here? Friction, quick. Hmm? 6, 350. 315.1. 315.1. 315.1. Okay, so 315.1. Okay, now, so now we'll have to see what it is accelerating upward direction, right? So collect all the forces that are parallel to the plane. What are the forces acting over here? If it goes in the same direction means positive, but parallel but opposite means minus. So what are the forces? Tell me. So minus friction minus weight component. Okay, minus weight component that is equal to mass into acceleration. Because of that only what? It will come to rest. Because it is decelerating because of the opposite force. So what is friction? Minus 315.1 minus weight component 800 sine 10 degree. So these two forces only what? Reducing the speed because acting opposite direction. Together is equal to mass. What is mass? 80 times A. Find A, that A to be used over here. So this is by Newton's second law. Resultant force is equal to mass into acceleration. You have to collect all the forces which are acting parallel to the acceleration direction. Minus 5 point. Okay, so now we know A, right? So in this comment, it's a constant acceleration only, no? So I can find what? Which equation to be used? V square is equal to U square plus 2AS for the given combination. Find S. Will tell you how many? will tell you how far it can go up, then come to the rest. 12.7 meter. So 12.7 meter it can go up. Okay. Now that is only 50% of some over. Now remaining, what do they ask? After it reaches the maximum height, no. They ask, show that he remains at rest. There will be remains at rest there without falling back down the slope. Which means what? After he reaches over there, no, he remains over there means what? Friction acting opposite direction. Weight component acting this direction. So both are going to be balanced. So the friction acting opposite direction, after he reaches over there, he tries to come back, right? So when he is here means only weight component acting this side, correct? And friction will be acting this side. So what is friction? What is weight component? And see, is it coming equal or not? If it comes equal means he remains over there. So friction will be what? Friction, it remains this 315.1 will be acting that side, right? So 315.1 will be here. Because same only here. Because R will be 800 sine 800 cos 10. Even if it comes over here, what? R is going to be 800 cos 10. If I multiply mu, same friction only will come, but acting opposite direction. Because after he reaches over here, what he does? He tried to come down, right? Because of weight. So if he tried to come down, friction acting this side. So friction here, weight will be here. Weight component also what? Same 800 sine 10. That is only going to be there. Okay. So now check 800 sine 10. See, if he has to be there, no, it's not required to be what? The weight component friction need to be equal. The friction exceeds weight component, so it will be there only. Friction should either be equal or it should be greater than weight component. In that case, he will remain over there. Correct? So if it is equal or if it is greater also, in both the case, he will remain over there. So 800 sine 10 degree and friction 315.1. So our friction is greater than 800 sine 10, which means what? He will remain over there only without falling down. That's done. So after he reaches over there, now some shifted over here. Okay. Now he is here now. See, after he reaches the maximum height, B becomes 0, then he tried to come down, slide down only, right? That time when he tried to come down, friction automatically changed direction. Whichever way we intend to come, the opposite direction only friction acts. So friction that side, weight component this side. So friction exceeds the weight component means what? That means the weight component is not having the sufficient force to bring it down. It has to exceed the friction, only then can fall down. So your friction exceeds the weight component, or you can say friction greater than weight component. That's why turbine is without falling down. When I try to find the resultant force, I have to connect all the forces acting parallel to the plane. Because I go this side only, no. These two forces acting this side, are they helping you to go up or against you? Against it's minus. You have to collect all the parallel forces, but see the direction. Is it the same direction to the acceleration is plus opposite direction is minus. Question. To learn how to get the resultant force, that you are able to find means that some will be over. Easily can find out all the answers.